Multiple URouters can be installed using the install switch, specifying a unique name, the protocol, and a unique network port. You may choose to do this to facilitate multiple environments on the same machine, for example, a development environment, QA, and user acceptance test. By having multiple URouters, it will be possible to stop one URouter without affecting another environment. Another reason you may choose to have multiple URouters is to provide a fallback path. We will see this on the next slide. Fallback paths provide fault tolerance by allowing you to specify multiple failover paths. The paths have the same format as a standard connection string, but have the addition of an index. This index must be a sequential integer starting at 1. If the first path fails, Uniface will fall back to the next path, and if that fails, to the next path, and so on until it gets to a path that works. The fallback URouters may be on a different host or on the same host. An additional setting to be aware of when using fallback paths is $net timeout and the CCT setting. CCT stands for Client Connect Timeout, and the default for this is 180 seconds. Uniface will not fall back to the next path until the Client Connect timeout. 180 seconds is usually far too long for a standard application, so you may choose to lower this value. Fallback paths are implemented for traditional desktop applications, but are not implemented for Uniface web applications. Uniface web applications can achieve similar functionality by utilizing the features found in typical servlet engines. We'll now look at multiple URouters and fallback paths. Here we can see my original URouter. So I'll now add a second from the command line using the install switch. Specifying my second name of Uniface 92 URouter FB. And I'll specify the port number 13033. This can be any free port on the machine. And we can now see it's in my list of services. So I'll start this URouter as well. So that's my multiple URouters installed, and I'll be using that as the fallback URouter. We'll take a look at the assignment file. So that we can see things happening, I've specified a second UST and specified a second UServer file. So I copied the original file and just called it _FB. This is just so that we can see it in Task Manager. If I now add my fallback path to the assignment file, so I'll just take a copy of the original path, add my index, and specify the new port number and the second UST, just so that we can see the actual executable. Just reconfirming the port, 13033 is the port we created. Okay, if we look in Task Manager, we should see the two URouters. I'll now start the application. When I do my first calculation, we should see the original UServer be created, because the first URouter is working. I'll now take down the first URouter, which will kill the UServer process as well. When I rerun the calculation now, we see the second UServer created, so my fallback UServer, which has been created via the second URouter. Now a thing to note here is the fallback was quick because I've set the client connect timeout in the assignment file. So $net timeout, and I set the timeout to 2 seconds. The URouter monitor is a 4GL tool written in Uniface that allows you to monitor the state of the URouter, the connected clients, and the pool of UServer processes that the URouter is managing. It allows for dynamic reconfiguration and a level of hot deployment on the server-side UServer processes. The URouter API provides 4GL access to the URouter monitor functionality. This will allow things such as dynamically starting and stopping instances of the UServer. It will allow you to write complex URouter monitors. It will allow you to dynamically reconfigure the URouter. The API includes a number of functions allowing you to fully utilize the functionality of the URouter monitor. We'll now look at the URouter monitor. If I start the URouter monitor and put in my machine name and the port of the URouter, I can then log on to the URouter monitor. And here we can see the current client and the current server processes that are running. If I double click that, I can see that it's currently handled one request. If I now start the client application, and I'll just do 3 additional requests. I can see I have an additional client, which is my new application that I just started. When I look at the servers and go back into that process, I can now see that it's processed 4 requests. If we look at the default server menu, it only has hide. If I go into URouter authorized, I have the option of becoming a privileged user. Now, the privileged user, I tend to create a user called URouter because this tends to be the easiest way to use this functionality. If I log in with that URouter user, when I now look at the server menu, I can see I have start and stop as well. Start will allow me to start additional UServer processes, so I'll try and start 10 processes. Specify my user that I use to log in, the password, and the type of UServer I want to start. So I'll go for Dojo, which is what I've been using. And we can see it started 10 processes, and the monitor also shows the additional processes. If I say servers stop, I have various ways of stopping processes. I'll just go by ID for now, so I'll enter ID 11. We can see that ID 11 has process ID 2052. So when I click OK, the process disappears and is removed from the list in the URouter monitor. Other functionality we have are reloading the assignment file, changing settings of the URouter, and changing settings of the USTs, so we can do plenty of things without restarting the URouter process. To summarise, the URouter is a multi-threaded server daemon. It incorporates intelligent load balancing of a pool of application servers. Multiple instances are supported, and this helps with a fault tolerance through the use of fallback paths. The UServers are the Uniface virtual machines. These can be run in a shared or exclusive mode, and a thing to note here is the use of a single port versus multiple network ports. That brings us to the end of the presentation. Thanks for watching.